Welcome back to Java Internals Crashcasts. I'm Sheila, and with me as always is the brilliant Victor. Today we're diving into the exciting world of concurrent collections, specifically the ConcurrentMap interface. Victor, are you ready to map out this concept for our listeners?
Absolutely, Sheila. I'm excited to explore this crucial interface in Java's concurrent utilities. It's a topic that's sure to add some thread-safe spice to our listeners' coding recipes.
Before we jump in, let's remind our listeners that we're in the third season of our series, focusing on concurrent collections. We've already covered queues and deckers, and now we're in the chapter about maps and sets. To get the most out of this episode, listeners should be familiar with basic Java collections and have a general understanding of concurrency issues.
That's right, Sheila. And for those who need a quick refresher, concurrency issues arise when multiple threads access shared resources simultaneously, potentially leading to data inconsistencies or race conditions.
Excellent point, Victor. Now let's kick things off with a brain teaser for our listeners. Here's the quiz question. In a regular hash map, if two threads simultaneously try to put a new key-value pair with the same key, what's guaranteed about the final state of the map?
Ooh, that's a tricky one, Sheila. It really gets to the heart of why we need concurrent collections. Without giving away the answer, I'd say this question highlights the unpredictable nature of multi-threaded operations on non-thread-safe collections. It's like having multiple chefs adding ingredients to the same pot without coordinating. You never know what the final dish will taste like.
Great analogy, Victor. Now let's start with the basics. Can you explain what the ConcurrentMap interface is and why it was created?
Certainly. The ConcurrentMap interface is part of the java.util.concurrent package, introduced in Java 5. It extends the regular map interface but provides additional atomic operations and guarantees about concurrent access and modification. It was created to address the need for thread-safe map implementations that can handle concurrent access efficiently without external synchronization.
That's interesting. So it's like a more robust version of the regular map. Could you elaborate on what you mean by atomic operations?
Of course, an atomic operation is one that appears to occur instantaneously from the perspective of other threads. It's all or nothing. Either the operation completes entirely or it doesn't happen at all. There's no intermediate state visible to other threads. For example, the put-if-absent method in ConcurrentMap is atomic. It checks if a key is absent and inserts a value if it is, all in one indivisible step.
I see. So it's like teleportation in a way. The value appears in the map instantly without any visible travel time. Now, what are some key methods that ConcurrentMap provides?
Great question. Some important methods include 1. Put-if-absent, key value. Adds the key value pair if the key isn't already in the map. 2. Remove key value. Removes the entry only if the key is currently mapped to the specified value. 3. Replace key, old value, new value. Replaces the old value with the new one only if the current value matches the old value. 4. Compute if absent, key mapping function. Computes a value if the key isn't already in the map and enters it. All these methods perform their operations atomically, which is crucial for maintaining consistency in a multi-threaded environment.
Those methods sound really useful. I'm particularly intrigued by the compute if absent method. How does it differ from a simple get-then-put operation?
Excellent observation, Sheila. The compute if absent method is more efficient and thread-safe compared to a separate get and put. In a multi-threaded scenario, if you first get a value and then put it if it's absent, another thread could interfere between these two operations. Compute if absent does this in one atomic step, ensuring that only one thread computes and sets the value if it's absent.
That makes sense. It's like having a security guard at a store entrance who checks your ID and either lets you in or registers you on the spot, all in one swift motion. Now, how does ConcurrentMap ensure thread safety?
That's a great analogy, Sheila. ConcurrentMap ensures thread safety through various techniques, depending on the specific implementation. For instance, concurrent hash map, which is the most common implementation, uses a technique called lock striping. This means it divides the map into segments and locks only the relevant segment during modifications, allowing a high degree of concurrency.
Fascinating. It's like having multiple security guards, each watching different sections of the store, instead of one guard trying to monitor everything. Can you give us an example of a real-world scenario where ConcurrentMap would be particularly useful?
Absolutely. Imagine a high-traffic e-commerce website that maintains a cache of product information. Multiple threads might be reading from and writing to this cache simultaneously, some updating prices, others checking stock levels, and others serving customer requests. A concurrent map would be perfect for this scenario, ensuring that all these operations can happen concurrently without data corruption or inconsistencies.
That's a great example, Victor. It really brings home the importance of concurrent collections in modern applications. Now, are there any common pitfalls or misunderstandings about ConcurrentMap that our listeners should be aware of?
Good question, Sheila. One common misconception is that ConcurrentMap provides absolute thread safety for all operations. While it ensures the atomicity of individual methods, compound actions, like check-then-act operations, may still need external synchronization. Also, iterators from ConcurrentMap are weakly consistent, meaning they may not reflect all the latest changes to the map.
That's crucial information, Victor. It sounds like developers still need to be mindful of how they use ConcurrentMap in their code. Before we wrap up, let's reveal the answer to our quiz question. Victor, would you like to do the honors?
Certainly. The answer to our quiz question is that for a regular hash map, there's no guarantee about which key-value pair will end up in the map if two threads simultaneously try to put pairs with the same key. It's unpredictable and could lead to lost updates. This is precisely why ConcurrentMap and its atomic operations are so valuable in multi-threaded environments.
Thank you, Victor. To summarize today's episode, 1. ConcurrentMap is an interface in java.util.concurrent that extends map, providing thread-safe operations. 2. It offers atomic methods like put if absent, remove, replace, and compute, if absent. 3. ConcurrentMap ensures thread safety, often through techniques like lock striping. 4. It's useful in scenarios with high concurrent access, like caching systems. 5. While powerful, it's not a silver bullet. Compound operations may still need external synchronization. Next time, we'll be discussing concurrent hashmap, the most common implementation of ConcurrentMap. Don't miss it.
It's been a pleasure mapping out this concept with you, Sheila. Remember, listeners, in the world of concurrent programming, using the right tools can make all the difference between a smoothly running application and a concurrent catastrophe.
Absolutely, Victor. And to our wonderful listeners, if you've enjoyed today's episode, please subscribe to Java Internals Crashcasts and leave us a rating. Your support helps us continue bringing you deep dives into Java's internals. Until next time, keep your collections concurrent and your coding crash-free.